Hello everyone, welcome back to another tutorial of Signal and Systems with MATLAB. In this tutorial, I am going to make a very basic ramp signal and then I will show you its continuous and discrete time part as we have been doing for the unit step signal, unit impulse signal, and now we are on the unit ramp signal. After this tutorial, you will have learned about the exponential signals, unit step signals, sinusoidal signals, unit impulse signals, and now at unit ramp signals. Then we are good to go to move with the advanced topics of signal and systems. To start this tutorial, let me show you what actually is the ramp signal. Basically, a ramp signal is a slope signal whose amplitude is same as its time. What does this mean that the amplitude is same as its time? So as you can see this very basic signal here, when the time is 0, its amplitude is 0. When it reaches to 1, its amplitude is 1. When the time or the sample size is 2, its amplitude is 2. For 3, it is 3. So for that purpose we can draw some conclusions about it. I will show you in next few minutes. So let me start writing my code. CLC clear all and close all. CLC clears the command window, clear all commands the clear all command clears the workspace, and close all command closes all the existing open windows. So let me initialize a time here, time minus 10. The step size will be 10, and then I will have to take the and my array at 10. So total it will have 21 values here. And now let me initialize a basic signal. So basically we know that the unit step signal is 0 uh, when the time is less than 0. Okay, and it has the value of 1 when the time is greater than 0. So the concept is, if we multiply a unit step signal with its time, then it will become a ramp signal. Make or to draw very basic ramp signals, we can use this technique. I will show it to you. Just let me write some lines here. So let me initialize a variable name signal. Okay, in this signal I have to make an array which is based on the zeros 1 colon 10. Okay, and 1 colon 10. Okay, and it has the row vector of ones 1 colon 11. Okay, fine. And to close this array we need to include braces. So now ramp signal, what will be the ramp signal? Time dot static signal. What I am doing here, I am just multiplying it, uh, multiplying our unit step signal with its time, and it will result in the form of a ramp signal. How? Let me show you in these lines. So let me plot it. Time comma ramp underscore signal. So I am not going to include titles or X label or Y label. I am just simply going to just visualize it, what it actually did to our signal. So there is no error in it. You can see that output is a very fine unit uh, ramp signal, because in unit ramp signals there is nothing less than 0, and from 0 to up to positive infinity it has the amplitude which is equal to its time. So at 10 its amplitude is 10, at 9 it has the amplitude of 9, at 8 it has the value of 8. Okay, so this was the basic concept about it. Yes, you can see that the value of x is equal to 8 and y is equal to 8. When we reach at this point, we have the value of x is equal to 7. It has the output of 7. And how we achieved this? We simply defined a time, and we then defined a unit, a signal which is similar to unit step signal, and then we multiplied that signal with its time. So when it got multiplied, the sample of 0 got multiplied by the 0. So 0 cross 0 is equal to 0, and the 1 the signal which has the amplitude of 1, got multiplied by with that signal with the amplitude of 1, and 1 cross 1 is equal to 1. So in this manner its ramp is created. Okay, so just let just let me add some beautification in this concept. Hold on and plot. And I, if we want to, it is not good practice to have both discrete and continuous time plot in the same graph for this very specific case, but no worries, let us practice. Okay, stem time underscore ramp underscore signal. Okay, and let me define a title for this. So its title is unit ramp signal. Okay, fine. X label uh, time and y label is equal to amplitude. Okay, I want to include legend as well. So for that purpose, I have to enter two attributes in it. First one is continuous time, and the second one is discrete time, and the next one is grid on and hold off. Now we are good to go. Hopefully it will not have an error. So stem. So let me show you what it actually looks like when we make a continuous time and discrete time in it. Okay, fine. So very amazing. We can place it here. Okay, from this you can see that we have made a very perfect unit ramp signal, and in this unit ramp signal, the amplitude of the signal is equivalent to the time of the signal. Okay, so we have created the discrete time unit step signal, sorry, unit ramp signal, and we have also visualized the continuous time unit ramp signal. Hopefully you would have liked this video. I will try to make few exercises on it, how you can make more signals like this in MATLAB. If you have any question, or if you want to make me more videos on such topics, or you want to make me video of your choice in the signal and systems domain, you can just simply leave to the comments. Do not forget to subscribe and like this video. Thank you so much.